Hello and welcome to another video. In this video, we will be discussing various block transformation techniques, basic transformation techniques, which will help us to reduce the block diagrams. In control systems, systems are represented by blocks with input and output. When there are many such systems, we will reduce the complicated subsystem into one single diagram. So the block diagram reduction helps us to reduce it to a single transfer function so that the analysis becomes easier. The analysis is done in the frequency domain. So this block diagram reduction helps us to reduce a system with many subsystems into one single block diagram, single transfer function. So that is done by various simple transformations. So that complicated is transformed with few basic transformations. We will see those basic transformations in this video. There are mainly 5 basic transformations. The first one is summing junctions. Second one is pick-off point. The third one is cascade form. In cascade form, we will have the product of those transformations where each block is kept in series. And in parallel form, each block is kept in parallel and the algebraic sum will be the simplified transformation. We will see all those in detail. And the final form is feedback form, which is the basis for our study of control system engineering. I had mentioned in the first videos the importance of closed loop control or a feedback control over open loop control. So in feedback control, we have a loop which closes the feedback system. So we will analyze the feedback system and we will try to reduce the feedback system into a single block diagram. To begin with, we will see what are the signals. So here R of S and C of S are the signals. And a system is represented as R of S given as input, C of S is taken as output, and system is represented by G of S. So G of S is the transfer function, the Laplace transform, the ratio of the Laplace transform of the input and the output. Now, the first reduction is summing junction. So summing junction is nothing but you will have a summer and you will have inputs R1, R2 and R3. So here it is plus R1 plus R2 minus R3. So R1 plus R2 minus R3. So this is the output. C of S is equal to R1 plus R2 minus R3. So that is the function of a summing junction. And pick-off point is nothing but this R of S is picked off or taken and given here as R of S, the pick-off point and the third pick-off point. So this is how the pick-off point works. Now this is a block diagram where the transfer functions are kept in series. So the output x2 of S is nothing but this G1 of S into R of S. Similarly, the output here is nothing but the whatever signal is obtained here, that is multiplied with G2 of S. So G2 of S multiplied with G1 of S multiplied with R of S. Similarly, this is the input here. That input is getting multiplied with G of S and given as the output. So the final output would be G3 of S multiplied with G2 of S multiplied with G1 of S multiplied with R of S. So that is equivalent to R of S given as input to G3, G2, G1. So C of S is our output. So both these outputs are same. So this 3 block diagram can be reduced to this single block with G1, G2, G3. So whenever 3 blocks are kept in series, they are multiplied to get the equivalent block. Now whenever 3 blocks are kept in parallel, R of S comes here. So this is the pick-off point and here you have R of S. and this R of s is multiplied with G1 of s. So R of s into G1 of s is the output here. Similarly, this is the pickoff point and R of s is given here to G2 of s. So X2 is nothing but R of s into G1 of s, G2 of s. Similarly, G3 multiplied with R of s will be the X3. And here you have a summa. It can be positive or negative. So G1 of s plus G2 of s plus G3 of s, or the negative signs multiplied with R of s. That will be the total output, C of s. So this equivalent representation is R of s can be taken here, and C of s is nothing but this R of s into G1 plus G2 plus G3. So whenever three blocks are kept in parallel, we add them or we subtract them based on whatever is here, whether it is plus or minus. Now comes the important feedback form. So here, this is a closed loop control system. The input is R of s, and we have a summing junction, and the E of s is the error. So that E of s is the difference between R of s and the feedback. So whatever the signal is coming here. So that may be either negative sign or a positive sign. So if it is a negative feedback, we have a negative sign. If it is a positive feedback, we have a positive sign. So this error signal E of s is multiplied with G of s to give the output. Let us first consider the case of negative feedback. So here, as I mentioned earlier, C of s is nothing but it is a multiplication of E of s and G of s. So E of s into G of s. From this equation, we will get E of s is equal to C of s by G of s. Now here the error E of s is nothing but whatever signal coming here R of s minus C of s into G of H of s. So C of s is a signal that is arriving here, that is getting multiplied with H of s, C of s into H of s. So that is when we are considering a negative sign, so R of s minus C of s H of s. That is a signal coming here, E of s. E of s is nothing but the signal coming here minus the signal coming here. And from here, we are substituting E of s. So E of s we had already obtained as G of s by C of s by G of s. So C of s by G of s is equal to R of s minus C of s H of s. Now I am rearranging, keeping only R of s on this right hand side. I'm taking this side and rearranging C of s plus G of s into C of s H of s divided by G of s is equal to R of s. Taking G of s the other side, C of s plus G of s, C of s H of s is equal to R of s, G of s. And we are taking from this equation, we are taking C of s divided by, we are taking C of s common from left hand side, and C of s divided by R of s, we are taking this to the left hand side. We will get C of s by R of s is equal to G of s by 1 plus G of s H of s. So this is the reduced block diagram. So we got a relation between output C of s and input R of s. Output C of s and input R of s. So this is the block that gives, this is the transfer function that gives a relation between output and input. So this total block can be reduced to this single block. So this is in case of a negative feedback. Similarly, for a positive feedback system, here we will replace this negative and with a positive sign. So here the change comes. Similarly, here this will be positive. Here this will be negative. This will be negative. And this will be negative. So this will be for a positive feedback system. This will be the transfer function G of s by 1 minus G of s H of s. So for a negative feedback system, it is G of s by 1 plus G of s H of s. And for a positive feedback system, we will get the reduced block diagram to be g of s by 1 plus g of s. Now we will see few more block transformations. The first one is moving a summer. Moving the summer from this point to this point. So both these are equivalent representation. So to reduce the block diagram, sometimes we will have to move the summer from one point to another. So here the input and the output should be the same. So here to maintain the output to be at c of s, we will have to multiply this signal x of s with g of s when we move the summer to the right. Why is it so? So on the left hand side, we have r of s added with x of s, and that signal, whatever is added, r of s plus x of s, that is getting multiplied with g of s. So r of s plus x of s into g of s. That is what c of s is. On the right hand side, we have r of s multiplied with g of s. That is the signal that is obtained here. And that is being added, that is being summed with x of s and g of s. So this both signals are equivalent. When we multiply g of s with taken inside, it will be r of s into g of s plus x of s into g of s. That is why we need another block when we move the summer from the left to the right. To maintain both the signals c of s, the right hand side, the output should be same. So to maintain that, we are doing this. So when we move a block to the right, we are creating a new block g of s to multiply with x of s. Similarly, when we move a summer to the left of a block, we will multiply with 1 by g of s. This is because on the left hand side, we have the output as r of s multiplied with g of s, r of s multiplied with g of s, plus x of s. So after multiplication of r of s with g of s, this x of s is added to get the output c of s. Now when we move the block to the left, we will have to multiply, create a new block 1 by g of s to be multiplied with x of s, so that the output remains the same as on the left hand side. So here the output is r of s plus x of s by g of s multiplied with g of s. So when you take it inside, it will be r of s g of s, and when you take it this inside, this g of s and g of s gets cancelled, and only x of s will remain, which is similar to the signal on the left. So whenever you move a summer to the left, you will have to create a new block which where the signal is multiplied with 1 by whatever the transfer function here, 1 by g of s. Similarly, when a pickup point is there. So here on the left hand side, we have r of s, g of s, r of s, r of s. So when we are moving the pickup point to the right of this block, so r of to the right of the block g of s, now the pickup point is here. You can directly pick up because it is the same signal, r of s, g of s, r of s, g of s. But here it will be multiplied with g of s. So we will have, after the pickup point, we will have to multiply with 1 by g of s to cancel out the effect of that multiplication of g of s here. So here we just need r of s, not r of s, g of s. So we will multiply with 1 by g of s. Similarly here, again 1 by g of s. We just need r of s here, not r of s, g of s. So whenever you move the pickup point, again you need to introduce new blocks to cancel out the effect of that moving the pickup point. Similarly here, r of s, g of s, the output is r of s, g of s for all the three different pickup points. So when you move this pickup point to the left, you will have to add new blocks for each flow. So here for each line, we will have to multiply with g of s individually, so that the moving of the pickup point, the effect is nullified. So these are the basic block transformations which will be helpful in block diagram reduction, which we will see in the next video. Thank you.